Hello. The next 2, 3, 4, 5 videos are all going to be what I'm going to call fun probability calculations. They're going to involve coins or dice or drawing balls from boxes or cards. And these are all problems selected from actuarial exams. And more specifically, I have a playlist on this site called Free Actuarial Exams. And these are just selected problems from those exams that I review there. And so here we're going to calculate probabilities with coins. So let's say A flips 2 coins and B flips 3 coins. The winner has more heads. If a tie, meaning they have the same number of heads on a flip, we repeat until there's a winner. And we want to find the probability that A wins. And I have 2 answers here, 2 different solutions. And I think one is probably more traditional and the other is a little more creative. The first one is more traditional. So let's let X be the number of heads A observes on a flip. Y is the number of heads B observes. F is the number of flips. So they could win on flip 1 or flip 2, and F is a counter for that. So on any given flip, the probability that X wins is this. It's probability that X has a 2 and Y is a 0, plus the probability that X has a 2, Y a 1, X a 1, Y a 0. Now, since these are independent flips, A is flipping his coins independently of B, it ends up just being the product. So the probability that we have 2 heads with 2 coins is 1/4. The probability that we have 0 heads with 3 coins is 1/8. Here, the probability that we have 2 heads and 2 coins is 1/4. 1 head with 3 coins, 3/8, 1/2, 1/8, and those are that is 3/6. But that's on any given flip, and they could tie. So what's the probability of a tie on a given flip? And that's this. It's the probability that X is 2, Y is 2, X1, Y1, X0, Y0. And then the respective probabilities of each of those flips. And so the probability of a tie on any given flip is 5/16. So now let's calculate the probability that A wins. And you kind of get the way that I think about this. So the probability that A wins, if we introduce another variable called flips, and then sum over all possibles for that variable, then this is the same as this. But this is a intersection, so the probability A wins and flip equals 2, And so that intersection can be written like this: a conditional probability, probability that flip equals I, times the probability that A wins given flip equals I. Now, a lot of people go from here to here, but I just think it's cleaner and more clear when each step is provided. Now, the next step is this piece here. Okay, so the probability that A wins on any given flip is 3/16. And so that's constant from flip to flip. Now, the probability that F equals 1, that's 1 or 100%, right? So when I equals 1, then I minus 1 is 0, and then this is 1, right? And then when I is 2, so the probability that flip equals 2 means that we tied on the first one, and then it's 100% that we have flip 2. So the probability that we tied is 5/16. So when I is 2, then we get 5/16 times the given flip. When I is 3, we have to tie on the first one and tie on the second one, and then the flip 3 is 100%. So this is 5/16 to the second, and that's what we get when I is 3. And then on any given flip, it's the same, 3/16. So this 3/16 can be pulled out front, And that's what we do here. And if we write these terms out, we get this, 1 plus 5/16, plus 5/16 squared, etc. So this is a geometric series, and this is less than 1, so it converges to this, 1 over 1 minus 5/16. You do the math, and the probability that A wins is 3/11. That's it. Now, solution 2 is this. So the probability that A wins is the probability that A wins and Y is equal to I. And Y is the number of heads that B flips in 3 coins. So he could have 0, 1, 2, or 3. So we're summing from 0 to 3. But then this can be written as a conditional probability, right? And so let's write a few of these out. So when I is 0, so the probability that Y is 0 is this. Now that means that Y is 0. So what's the probability that A wins? Well, it's the probability that A rolls a 2, or, which means plus, he rolls a 1, right? He still wins because Y rolled a 0. And here, so if Y is a 0 and A rolls a 0, he could still win, right, on the next roll. So the probability that A wins is X, is that he rolls a 0, meaning ties, and then on the next roll he wins. What's the probability that he wins? And so it's being reset in a sense. And so here, when I is 1, that's this piece. The probability that A wins when Y is 1 is probability it rolls a 2 plus the probability rolls a 1 and wins. Then on the next roll it's reset. And then Y equal 2. And then the probability that A wins is that he rolls a 2. And then it's reset that he wins. So it's times the probability whatever that he wins. And then when Y is 3, there's no way that A can win, so that's 0. So I just leave it out. And now here, we start filling in the gap. So probability that Y is 0 is 1/8 times 1/4. 1/8 times 1/2. So that's here and here. And then we have 1/8 times probability X is 0 is 1/4. And then, of course, times the probability that he wins. And then the same way, probability that Y is 1 is 3/8, so that gets multiplied into 1/4, and so this is 3/8 times the probability that 1 is 1/2, and then times probability that he wins. So here Y is 2 is 3/8, X equal 2 is 1/4 times probability he wins. Now let's group like terms. So there's all these probability he wins. There's a coefficient in front, and then we have coefficients that without a probability wins, and that's what we get here. Then we subtract that to the other side and factor it out, so we get this. Then we divide that, and we get probability that A wins is 3/11, the same as what we got here. Now this problem, a coin is flipped and tail ahead. Now given a head appears on an even toss, find the probability that a head appears on the 4th flip. I should have said flip there, but so the answer is X is equal to the number of flips to the first head. So this is the probability of that. It's a negative binomial, and so or geometric since it's 1. So this is it. So we probability X, so that means it took X flips to get ahead. So that means we had we had X minus 1 non-heads, and then we had 1 head. But these, since flipping a coin is 1/2, that's all 1/2, so it's just 1/2 to the X. Now the probability that X is even, well, that means on the second try, so he flipped a tail and then flipped a head and won. So that's 1/2 squared. And then that he wins on the 4th try is he flips 3 tails and then a head, so that's still 1/2 to the 4th. Wins on a 6 try, and etc. So he keeps going. Now, if we square that, we get 1/4, and then we take one of those and get 1/4 squared. This is 2 times 3. Oh, that should be 1/2 right there. And then, so then, I don't know where my pen is. So this is 1/2. So this is 1/4 third. So this is a geometric series. And the first term is 1/4. So that goes there. And then we get 1 minus 1/4. That is 1/3. So now the probability that x is 4, given that x is even, is this. Probability that x is 4 over the probability that x is even. Plug in the numbers, right? X is 4 is this. Probability that's even is this. Multiply it out, you get 3/16. So here, and the last problem, a coin is flipped. If it's a head, roll 1 die. If a tail, roll 2 die. Let y be the total on the die or the dice. Find the probability that y is equal to 6. So here, if we let 6 equal the outcome on a coin, we want to find the probability that y is 6. So we introduce a variable and sum it over all possible values. It's I can be a head or I can be a tail. So this probability is the same as this. But then this can be written in the conditional probability sense. So now we write that out. So let I be a head, and we get this. And then I is a tail, and we get this. So the probability that the coin is a head is a 1/2. The probability that it's y equals 6, given that the coin was a head, meaning we roll 1 die, so it's 1/6. Here, probability that the coin is a tail is a 1/2. Here, the probability that y is 6, given we rolled a tail, which means we roll 2 die, so that's 5/36. So we add this up, we get 1170 seconds. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.